Hi to all the judges. My name is HENG HUI SHAN and my matrix number is 18688. My final year project title is the Development of Design and Installation Checklist for GULLY-TYPE program in meat processing factory based on hydraulic and hygienic analysis. And my supervisor is Dr. Noor Zafira Noor Hassan. And the common drain in food processing is gully and channel drain. The poor drain will have the ineffective wastewater removal and they can be a source of food contamination problem. So Factory Y is a producer of a burger meat patties. They are having flooding and hygiene issues due to the poor design and installation. So my objective is to evaluate the impact of design and installation of flow drain on hydraulic efficiency and also hygiene efficiency in the meat processing facility. And after that, I'll need to propose a design and installation checklist for flow drain in wet area for meat processing. This is my significance of the Food Hygiene Regulation 2009 also states that the drain should be made of the adequate smooth type material and fitted with the food tray. And an appropriate gully should have a grating and a mesh basket to capture the solid object contained inside the gully body and connected to the piping outlet. So the gully is a square drain design range from 100 to 400 nm, and the hydraulic capacity range from 0.4 until 11 liter per second. And the hydraulic efficiency measures the hydraulic performance of a drain. The hydraulic capacity and hydraulic efficiency can be calculated using the equation. So the safety problem is slip, trips, and falls due to the poor hydraulic efficiency. And if the drain is not cleaned effectively, I found that the cigarette is the common source of contamination. And this is the company's profile. And this is the drain tool, which is the only functioning drain inside the factory Y due to location and sloping problem. And it is a GULLY-TYPE drain, but it is just a one-piece stainless steel structure and the surface is very rough. And there is no H-in fill at the flow to drain interface, so that there will be a potential wastewater accumulation. And the gully body is just made of the pouring material, and there is no waste basket also. And this is the floor plan of Factory Y, where the location of drain tube is under the flaker machine, which produce large amount of wastewater, and the point A and B in red is represent the severe flooding point. And this is my project workflow. And I use these two equations, the hydraulic efficiency and hydraulic capacity equation, to measure the hydraulic performance of the drain tool in Factory Y. And the HC is the hydraulic capacity, can be calculated using this equation, while the HL is based on the flow measurement, and I assume 90% is wastewater according factor on 2013. And I study the design and installation features of the current drain to evaluate its hygienic performance. And then how I measure the hygienic performance of the current drain. I use two methods, which is using the ATP illuminator to measure the presence of the organic matter. And I conduct swab tests also of the current drain, and both I conducted after cleaning and at different locations like the surface and the edge and the pores, and also the inside of the gully body, the soil water inside the gully body. And then I take the three sampling times, and then I take the average reading. The reading of the ATP illuminator can taken immediately, but the swab test result I need to send to the lab and then wait for the cultivation of the bacteria, and then I need to wait for the result. And the result I analyze based on the benchmark, which assumes the ATP reading benchmark must lower than 500 RLU per 100 cm square. And this table is the microbiological guideline of bacteria on food and non-food contact surface, such as for the aerobic bag count and E. coli and Listeria. Okay, so the checklist development, I developed the checklist which divide into the design and installation part for wet meat processing area. And this is my result. This graph is generated based on my observation. If the water depth is not closed, the number of the hole increase and the level of flooding increase. This equation shows a positive relationship between the number of holes and the level of flooding. I generated using the Excel based on this graph. The maximum level of flooding in location A and B is found to be 14.2 and 15.1. And then I calculated the inlet flow rate or the hydraulic capacity of the current drain, and also its hydraulic efficiency using the two equations just now in the chapter 2 at different number of the holes, where the total number of holes of the current drain is 81. For example, when the 71 holes are clogged, the inlet flow rate becomes very low, and also the hydraulic efficiency. And this table present the result of the ATP illuminator and also my microbial swab test. These readings are very high, which violates the benchmark, indicate the current drain is not effectively clean. One of the reasons may be the rough surface, as illustrated in this picture. The draining surface the surface of the drain is rough, is pitted with crevices. And the checklist, this is the design checklist, and this picture is I generated using the AutoCAD, which shows the minimum required components of a gully point. And the design checklist divided into several parts, which consists of grading, frame, seal basket, and so on. And then this is my installation checklist. I do a review of the current drain using the checklist, and I found only 16.67% compliances for the design checklist and 27.27% for installation checklist. So the low score validates the usefulness of this checklist. Okay, so this table presents my design drawing using the AutoCAD also. This is the top view of my design drawing. The square frame thickness is 5 mm and the radius corner is 3 mm. This is the view in wireframe. And this too is the side view. The U-shaped profile is at here to prevent the accumulation of the wastewater. And this side view can see the internal structure, which shows the presence of the minimum required components. And it's a double pipe wall to resist the thermal change and 45 degrees speaker outlet to ease the cleaning process. So the hydraulic and hygienic performance is really affected by the drain design and installation. So the checklist I developed can serve as a guideline for the SME of meat industry. But I think the model design by me using AutoCAD need to be tested using the software like ANSYS. And also I encourage to understand more on the effect of design and installation on the channel type. Okay, this is the reference, and So that's all for my presentation.